Basically, as we're going to learn through this series, is the fact that each one of the questions on the UIL competition test is basically going to be the same. Whether you take a state test from 19 or from 2019, or if you take a regional test from 2017, question number one is basically going to have the same type of idea. Question number two, number three, each of them basically have the same ideas. So today we're going to begin looking at question number one. And to do this, we're going to have to kind of do a couple of little updates and make sure you understand how basic number systems work. So to do this, we're going to begin by looking at our normal decimal number system. Now, when we're talking about decimal number systems, we're talking about our number system like we use here in the United States and like most other countries use. Decimal number systems is a number system based off of a 10 number decimal system. A 10 number decimal system includes numbers that go from 0 to 9. They do not actually include the number 10 because, as we will see in just a moment, the number 10 actually is where it starts over. We move up from 0 through 1 through 9, and when we hit 9, we flip back to 0. But now we have moved over one digit to the tens place. And so we begin starting out with a ones place. We have the ones place. We have the tens place. We have the hundreds place, thousands place, 10,000s place. And as I said, most systems use something along this line because this is the basic system. It's easiest to use. We have 10 fingers, 10 toes. And so because of that, a 10 or a decimal system is how most people think about numbers, money, etc. So we can go from 0 to 9 in the ones place, but then when we get to 9, it flips over and now starts out at 0 again in the 1. The 10 goes up to a 1. We would go through 1 to 10 or 1 to 9 again here in the ones, and now our tens place moves up from 1 to 2. And our 0 goes back to the ones place. Same thing if we were at 100, 1,000, 10,000, 100,000, all the way up through infinity. Our numbers are basically going to be repeating themselves, starting at 0, going to 9 in the ones place. And then when it hits 9, the next number over is going to go up. When that one hits 9, the next number over continues the same way. Most likely you remember some of that from elementary school math. Now, with base 10 numbering, we deal with, as I said, the numbers 1 or 0 rather to 9. And if you count that out, that's 10 numbers, 0 being the first, 9 being the last. You'll notice, though, that in this case, and you may have to remember your algebra from high school. So when we start out, the very first thing that we have is what we would call 10 to the 0 degree. 10 to the 0 degree is going to give you 1 because any number to the 0 degree is going to automatically be 1. Then the second place, so that's our ones place. You wouldn't have got this in elementary school. This would have been high school algebra. The second place is going to be your tens place. Well, 10 to the 1 power is tens place because it's anything to the 1 power is itself. 10 squared is the next place, and that would be our hundreds place. So 10 to the 0 is our 1 because everything with a 0 power is 1. 10 to the 1 power is itself, so that's our 10. 10 squared is 100, so that's our hundreds place. 10 to the third power is going to be our thousands place because 10 to the third power is 1,000. 10 to the fourth power is our 10,000s place. And it keeps going up just like that. Now, I know that was a quick recall of decimal places. You will notice that just like it keeps getting bigger, the numbers at the same time will keep, if you were going dividing or using a fractional version, you would end up with decimal places. And so That's where our decimals come from as well. Okay, so the first thing we need to understand with that is how that relates to binary systems. Now, while we as normal non-computer tech people use a base 10 system, which is what we call decimal, and you may see it written as decimal 10, you may see it written as 250 and then a subcase 10, subscript 10 rather. Binary is going to be a two number system. And our decimals, we're going from 0 to 9. Well, binary only has two, and all of our number systems will start at 0. So binary system is only going to have the numbers 0 and 1. Okay. So with 0 and 1, these two numbers together are going to create for us our binary system. And basically, computer technology, and even starting back in the early 1900s when computers first began, computers using just zeros and ones, true and false, off and on, this type of idea, were able to send a person to the moon, able to win world wars, able to figure out basically how to come up with microprocessors that now, instead of filling a whole room, can actually fit in the palm of your hand in a phone. And so, starting out with binary, zeros and ones, they have been able to do many, many, many things that a normal person or system would be able to do. So, similarly to the decimal system, we're going to have place values. The very first place value is the ones place. The second place value is what we're going to call the twos place. And like the decimal places, you're going up 1 and then 10, and then 10 times 10 is 100, and then 100 times 10 is 1,000, and so you're multiplying by 10 each time. You'll notice that each of these are multiplying by twos. So to go from the ones place to the two place, you're multiplying 1 times 2. To go from the twos to the next place, which is fours, you're multiplying it times 2, and it keeps going up. We get the same idea with our 2 to the 0 power, 2 to the 1, 2 squared, 2 to the third. Okay? So, if I wanted to create a 1, just the number 1, I would put a 1 in the ones place. See if I can make that a little broader of a stroke. Okay, so if I wanted just a 1, it's going to be the ones place. And each time, because this is binary, just like the decimal system, that each space can only hold 9 and then it rolls over, or it can only hold 0 to 9 and then it rolls over. The biggest number it's going to be able to hold for binary is 1. So if I put another 1 because I need to make 2, all of a sudden we have a problem, because the ones column cannot hold a 2, because all we can hold are zeros and ones. So what we have to do is we have to roll that new number over, and that new number is going to move over here. And this one's going to become a 0. Now, if I want 3, so we have 1, 2, and 0 ones. If I want a 3, I would put another 1 right here. We have 1, 2, and 1, 1, which combine to make 3. But if I want 4, I put a 1 here, plus 1, but it can't hold it. So it's going to roll over. So we put a 1 here, but it can't hold it either. So it's going to roll over, and it's going to give us the 4. Well, because these now don't have anything in them, they're going to be replaced with placeholders or zeros. So 4 is going to be 1, 0, 0. Okay. So if I want 5, I can put a 1 right here and replace the 0. If I want 6, because the 5 is 4 plus 1, that's why the 1 would be there. If I wanted 6, I would add another 1 to this spot and it's going to roll over to the next spot, which gives us a 2, leaving the 1 placeholder here, or the 0 placeholder here in the ones. Now we have 4 plus 2. 4 plus 2 makes 6. To make 7, the 0, we're going to put a 1 right here. 4 plus 2 plus 1 makes 7. Now to get 8, if I put a plus 1 here, we realize it has to roll over. Plus 1 here, it's going to have to roll over. Plus 1 here, it's going to have to roll over. So now we have 8. However, all of this is going to be replaced with placeholders because there are no 4s left, there are no 2s left, and there's no 1 left. Okay, so that's basically taking our system to understand how we build our binary numbers. You can look down here, and for decimal 0, binary would be 0. For decimal 1, binary is 1. For 2, it's 1, 0, because you would have 1, 2, 0, 1s. For 3, you're going to have 1, 2, 1, 1, which will make 3. 4, you're going to have 1 in the 4s column, but 0 in the other 2. 5, you're going to have 1, 4, and 1, 1, because that makes 5. 6, you're going to have 1, 4, 1, 2, and 0, 1s. 6. 7 is 1, 1, 1. 8, as we just showed, was 1, 0, 0, 0. And then 9, you would start again here and put a 1. When you get to 10, you'd add another one there, but it would have to roll over. And then you would put another one for 11, and it keeps going up the same way. You always start in the 1s column first. And then you're going to move things over after if it runs out of space in the 1s column. Okay, so let's look at how we would take this and go from decimal to binary numbers. So for me, the easiest way to go from decimal to binary is to start out with a number such as the number 5. Well, we already said that 5 is going to be 101. So we could say, okay, 5 in these numbers, 1, 2, 4, 8, 16, 32. Which one is the biggest number that can be taken out of 5, subtracted out of 5? And we'll notice that 4 is the biggest number that can be subtracted from 5. So for 5, we're going to need 1, 4. Now, we can ignore everything above that. We're not going to use any of the other numbers. So with 5, what do we have left? Once we take the 4 out, is there 2 left? Well, no, that would make 6, and that wouldn't work. We're only doing 5. So there is 1 left, and so 5 would be 1, 0, 1. Okay, so let's try this with a bigger number like 12. Well, if we look at the number 12 and we're trying to put that in a binary format, we'd first ask ourselves, okay, can I subtract 16 from 12? The answer is no. So that's too big. Can I subtract 8 from 12? And the answer is yes. So I have 1 8. Now, 12, after I subtract the 8, we have 4 left over. Well, here's 4. So I'm going to have 1 8 and 1 4. But do I have a 2 left after that? No. Do I have a 1? No. So basically, in this case, 12 is 1 1 0 0. Okay, so let's go with a bigger number. Let's try the number 142. So take a moment, pause the video, and try to see what you can find out. Start out by asking yourself, what is the biggest number that can be taken from 142? Okay, hopefully you were able to take a moment and try to figure out this answer. The biggest number in our set here that can be taken from 142 is 128. And so on the computer science test, you will not have a calculator. So do regular math. 142 minus 128. And we're going to have a 12 there, a 3 there. And we don't have to borrow from the 1, so we're good. 12 minus 8 is 4. 3 minus 2 is 1. Okay, So we have 128 is our first number. Now, the remaining amount is 14. 14 is, or the difference is 14. Can 64 go into 14? Well, no, we can't subtract 64 from 14, so we're going to put a 0. 32 come out of 14. Well, the answer is no there as well. Can 16 come from 14? The answer is no. So we have a 1 and 3 zeros, a 0 in the 64, 32, and 16 place. So the next biggest number that can come out of 14 is 8. So I'm going to put a 1 in 8. We're going to take the 8 out of the 14, which leaves us 6. Now, in 6, can 4 be subtracted from 6? The answer is yes. And so we're going to put a 1 right there. And now, can 2, that leaves 2. Can 2 be subtracted from 2? The answer is yes. So we're going to have a 2. And when you subtract that out, you get 0. And so 1 cannot be subtracted from that final number. So if you were to go to a binary calculator, 1,000,1110 is going to give you the number 142 in decimal. So going from decimal, like a number like this, into binary code, you just break it down by what numbers can fit in, and we can only go from 0 to 1. And every time you go from 0 to 1, it has to roll over to the next. So in this case, we've actually looked at a couple of different things. We've looked at how you can take the binary numbers, like zeros and ones, and the decimal numbers, and how you can go from decimal to binary. Well, the inverse is also true. So let's say I had the number 1,1,0,1,1,0, and I wanted to figure out what this is. So this, to me, is actually easier going from binary to decimal because we literally just add the numbers up. So 32 plus 16. Is there an 8? No, there's 0 8s. There is a 4, and there is a 2. We have no 1s. So 6 plus 2 makes 8, plus 4 makes 12, plus 2 makes 14, 3, 4, 5. So the answer would be 54. And you can look at it and see that 32 plus 16 is going to make 48. And then you have another 4 with 48, which makes 52. And then 2 more makes 54. So going from decimal to binary, you just break the numbers down based on what the biggest number is that can go into your decimal number. And from going from binary to decimal, you're going to go the opposite direction. You're going to look at what numbers fit in with the categories and what numbers are, and then you're just going to add those different categories together. Okay, so here is a question. This question, as you can tell at the bottom, was found in the 2021 invitational, first invitational, so the one in January. And it says, which of the following decimal numbers is equivalent to the binary number? And then it gives us 111,0,0,111. Well, as you can tell, they've already given us the answer here, but we need to work this out. So we're going to start out with, and we need to have our numbers. So 1, 1, 1, 0, 0, 1, 1, 1. Remember, the first column is your ones column, twos, fours, sorry about that, 8, 16, 32. I thought I made these far enough apart, but I guess not. 64 and 128. Okay, so now we just add the numbers together. So we have a number in the 128s column. So we need 128. We have a number in the 64s column. Have a number in the 32s column. We have a number in the 4, a number in the 2, and a number in the 1. So 128 plus 64. Maybe I should have written this up and down. 8 plus 4 is going to be 12. 2, 6, 8, 9, and 1. Plus 32. It's going to be 4, 9, 10, 11, 12. 224. 25, 26, 27, 28, 29, 30, 31. So our final answer, oops, how did I end up doing that? Anyway, our final answer is going to give us 231, which is hopefully the answer they've given us here, which was 231. So if you're looking at a question like this, you can easily take the binary number they've given you and created yourself a decimal number to come up with the same type of answer.